And now I would like to invite our third speaker for today. And I'm very happy to have Professor Raisa Mäkipää with us here in the seminar. And you're working at the LUKE, the National Resource Institute in Finland. And you're focusing here on the soils in our forests. So Katarina, we're focusing on the agricultural soils, and now we will move into the forests. And I know you have some quite exciting engagement in different kind of projects. For example, and if I pronounce this correctly, the Cameo project, where you are aiming to provide sort of a novel climate change mitigation concepts. And if I understand it correctly, you also want to increase the collaboration between various stakeholders and to have an impact on Finnish climate policy. So here we also have this policy connection, which I hope we can discuss more later. So Raisa, I'm very pleased to have you with us, and let's see if we can transfer to your presentation and get you up and running here.
Okay, thank you for invitation and kind introduction. I tried to share my screen, and let's see whether you can see it there.
Yes, we can see it. It's not in full mode.
I will change it to full mode, but then I lose the control with others. But you can hear me and you can see I moved to full mode and hope it.
Perfect. Thank you so much.
Okay, thanks again. So my presentation is about forest soil and the carbon sequestration potential, and I will start from global.
Raisa, can I just ask you, I think right now we can see your sort of next slide mode. So if you go into the top and you can change into view.
I will change to
yeah, I think that should make the trick.
Perfect. Okay.
That's excellent.
Okay. Thank you, Maria, so much. So I will start from global perspective and emphasize the global role of soils and forest in greenhouse gas balance, and then I will discuss about soil in climate convention and in national greenhouse gas inventories, and end up with some forest management practices and their role in soil carbon sequestration. That's my plan today. And this slide or similar one you may have seen several times. It shows that the global emissions, the sources for greenhouse gas emissions are about 10% from land use sector, from loss of forest, and remaining of largest part, more than 90% comes from fossil sources. And then we have carbon sinks in oceans and in forests. And I want to emphasize this role of forest. More than 30% of the carbon dioxide emitted to the atmosphere, it's sequestrated by forest, and therefore reduce the rate of climate change. What does that mean in long term? Sorry, hopefully not COVID pandemics here. So what does it mean in long term in global climate? This is kind of illustration what we have emitted since 1870, and how those emissions increase CO2 concentrations in the atmosphere, and then the current level of the current concentration, current CO2 concentration in atmosphere is 405 ppm, and without these carbon sinks in oceans and in terrestrial ecosystems, it would be already 550 ppm. So forests and oceans really have role in mitigation of the climate change. They have had that, and hopefully they have that also in the future. And that's already acknowledged internationally and included in climate targets of various countries. After Paris Agreement, EU has included forest carbon sinks and targets to regulations. We call that land use change and forest regulation. So there are targets for carbon sequestration in the forest, and majority of the developing countries have included land use sector in the national determined contribution, which means that they have a plan how much carbon they are aiming to sequestrate by agricultural practices or forest practices. And all countries are currently reporting their carbon sinks as a part of their greenhouse gas inventory. So internationally, in global scale, we also follow what countries are doing and how well they are reaching the targets what they have set and agreed internationally. And now we come to Finland, from where I will show this example. It's net greenhouse gas emissions and removals of the land use change and forest sector. That's left, and then more details about forest sector on the right hand side. And this is something what all countries are reporting. And in Finland, if we see whole sector, which is net sink of carbon, there are also carbon sources. Croplands are carbon sources, as we learned already from previous presentations. And forest land in general, it's carbon sink. So negative values are nice for the climate, because this negative side here indicates that there is a carbon sequestration. So forests as a whole, they are carbon sinks, and also this green part is wood products, so they are also carbon sink in case of Finland. But agriculture and settlements are carbon sources. Then if we go to the more details of this forest sector here, then we can see that there are also emissions in that sector. It's not all carbon sink. When we go to the forest, there is carbon sink of trees, this red one, and then there is a carbon sink on mineral soils. But then in forest land, organic soil, so peatlands managed for forestry, trained and managed for forestry, they are carbon sources. So not only good things, but something where we have relatively large emissions also in forest sector. I already mentioned that countries annually submit their national inventory reports to climate convention, and soil greenhouse gas emissions and removals are reported according to these categories. But this is something what I want to underline, that in most recent submissions, all EU countries were able to report they biomass carbon stock changes. So trees, they report and they have some information on that. But when it comes to dead wood, or when it comes to soil on forest soil, on mineral soils or peatlands, there is only 9 and 13 countries who are able to report anything. Others don't have any numbers, which means that soil carbon sink estimate is really highly uncertain in Europe. And if you want to have overall picture about role of soil carbon sink or source in Europe, we have to improve these methodologies which are applied across the Europe in the inventories. That was the first message. At European scale, more methodological development is needed in order to report carbon sinks and sources in all countries. But then I promised to talk a bit about effects of forest management on forest soil. And this is just to illustrate what management in general means to the forest. This figure is for biomass carbon stocks from clear cutting to forest stand at age of 100 years. And here we have a trend where trees grow, there is the increasing volume and increasing biomass in trees. And these drops here means that there is a thinning, so part of the trees are harvested, and that's the reason why biomass carbon stock decrease in those points. And in general, it is so that in unmanaged forest there is more biomass. They are stocking density is higher, and they sequestrate more carbon than managed forest, and that holds also in a long term at ecosystem scale. Even when trees start to grow slower, there is accumulation of the carbon in dead wood and soil carbon pool. And this illustrates soil carbon pool, what happens, and the stand age is here from clear cutting to 100-year-old stand and soil carbon stock. And after clear cutting, there is a decrease, and in the case that you follow this development of trees, then carbon sequestration continues up to the 100 years and reach the carbon stock which was there initially in the beginning of the rotation. So anyhow, in managed forest, carbon stocks tend to be lower than unmanaged side, and this is simulations what I show here in the figures, but empirical data from quite representative data set repeat the results, so it's consistent with empirical results. And this is simulation about same thing for region where we have unmanaged sites, and then two alternatives for management: continuous cover forestry or rotation-based forestry. In both cases, it's so that carbon stocks in soil, this part of the column, and carbon stock of trees is higher in unmanaged site, and this is on regional scale, and not too wide differences between these two management regimes. Then I want to remind you that in the European scale, it was so that only very few countries were able to report soil carbon changes for peatlands, for peat soils. And all those countries who were able to report soil was emission source. So peatlands were emission source in all those countries who were able to report that. And in Finland, we have studied that in more details, and we know that fertile trained peatlands are emission source, not that much less fertile sites. So we have site types, and most fertile classes are 1 and 2, and there we have relatively high emissions and total what we calculate for whole country. It's also remarkable in our greenhouse gas balance. But anyhow, here the message, you don't have to read the whole busy table. Here the message is that fertile trained peatlands are emission sources in boreal conditions, and it's because because of the drainage, and then we have a relatively thick organic layer which is decomposing and producing high CO2 emissions. Then we have developed methods where we can identify which parcels or which forest parcels are emission source. We combined the model for soil hydrology and and models which predict greenhouse gas emissions as a function of soil water table and site fertility, and we were able to derive these estimates for state-owned forests. So colored part are those forests which are operated by Metsähallitus, meaning that they are owned by government. And for those parcels, we calculated where are the emission hotspots, and we're able to identify. So the red spots here indicate that there is a peatland site where soil is a high emission source. And now this information is merged to their planning system, and they try to invent new methodologies how to manage these sites to reduce soil emissions. But anyhow, we have spotted where they are, so that's something what might help manage forest managers. And what can be done to reduce emissions? What we are testing now is continuous cover forestry. And here the idea is that in conventional even age management, we have relatively low water table when we have standing stock there. And then after clear cutting, it's elevated, and there is need for further ditching and to reduce the water table and to allow trees to grow. And this regeneration needs maintenance of ditch network, and this is harmful to aquatic systems and to greenhouse gas emissions and also to biodiversity. So alternative might be to go for continuous cover forestry and to go for selective cuttings and to remain standing volume over 100 cubic meters there all the time. And we already know that if water table is kept under 30 centimeters, there won't be methane emissions. And this is in relative terms as a function of groundwater table. So the water level there, we see that CO2 emissions are higher with the lower water tables. So we are aiming to maintain water table somewhere around 30 to 40 centimeters if possible. And we have already demonstrated with experimental studies that by selective thinning, by reducing evapotranspiration of the trees, we can, and leaving ditches as they are without further maintenance, we can elevate water table to some extent. So it looks promising, but we still need further measurements from those sites. And this is actually just repeat what is the concept, what we are aiming to do. So we aim to get water table to reasonable level, which means that CO2 emissions are reduced and methane emissions won't be increased. Then I go to conclusions. Maybe I don't read these through. I just emphasize that forest and forest soils have large impact on global carbon balance, and they also contribute on soil on overall biodiversity. Soil biodiversity is important component for ecosystem biodiversity. So we have to kind of find sustainable management practices in forest to maintain soil carbon sequestration capacity and to reduce CO2 emissions from peat soils and to maintain soil biodiversity. And currently, our tools and reporting methods are not comprehensive and uncertainties are large. There is a lot to improve. We have some views about more sustainable management practices, but we need more testing in order to reduce emissions and negative environmental impacts. And yes, further research is needed on soil processes. And my final slide is just remind you that World Soil Day will be soon, 5th of December, and you can find more information about events and webinars and links from website maintained by FAO. So thank you.
Thank you so much, Raisa. Thank you for that presentation. You went through a lot of different things here, but you definitely talked us through and gave us some details on the carbon in forest, looking at the living biomass, looking at the mineral soils, and then looking at the organic soils. You also mentioned at some points one of the challenges here, which is how can we actually sort of measure and what is it that's being reported and what are the uncertainties in that. And I think maybe that challenge is something we can come back to. And then you, by the end here, you came into peat soils and the water tables. And I would like to, if that's okay with you, Raisa, pick at least one or two questions from the chat function here.
Nice.
So someone is asking here, it's Justin Berglund wondering, how do you keep the water table at 30 centimeters in practical forestry? Do you have any reflection on that, Raisa?
Yeah. Thank you for this this question. It's repeated several times, and it's relatively stupid from a scientist to say that we keep that in 30 centimeters. It's not possible to keep that exactly somewhere. There will be variation anyhow, depending on vegetation, depending on precipitation and conditions. But but in principle, we are aiming to elevate it from the present stage, and we keep on saying that the target is 30 centimeters because it indicates that we try to keep that at the level where we have a top layer with living roots who are doing well. And then over the growing season, it should vary around that. And any increase, now the water table might be as deep as 80 centimeters or with new ditches down to 1 meter, which is absolutely too deep. And we try to do what we can to elevate that. But you are right, our question is smart. It's not possible to keep that exactly at that level. It varies.
Thank you for that answer, Raisa. I hope you are happy with that, Justin. I also have another question here, Raisa, for you, and it's with regards when you talked about the effect of management on soil carbon stock, and you had two diagrams on that slide. And it's Vilda Haukenes who's asking, can we say that after a clear cut, the soil carbon storage is restored after around 70 years? Is that a correct sort of interpretation of your figures there, Raisa?
In general, it's correct, but then it very much depends on vegetation, and I have to also underline that holds for mineral soils. In peatland, it doesn't hold. There we are losing carbon at the rate which is not kind of recovering with the growth of trees. It's all time releasing from soil this carbon by the composition of the peat. But on mineral soil, it holds in general, but depends on vegetation and trees. And if we have very if you continue management with very heavy thinnings and leave very little trees behind, then it might lead to loss of carbon also in older forests.